Good morning, students. Today I will discuss what is excitation system, what it is mean. So first of all, we know we have two type of generator. One is AC, another one is the DC. Again, we have divided the AC generator of the two type. One is the called synchronous and another is the asynchronous or induction generator. For generation of the use power, we use synchronous generator, and to operate synchronous generator we need two type of input. One is the mechanical energy while the another one is the electrical energy, and that's why we call it a doubly excited generator, because we are giving the two type of input. The second one, in which we use electrical input, that electrical input is a DC input, in which we provide the DC current or DC voltage across the field winding, and the system which provide the DC current or DC voltage across the field winding is termed as the excitation system. A very simple definition of the excitation system. In modern excitation system, we have regulation property, control and protection property as well. So finally we define the excitation system is a system which provide excitation power, which may be DC or AC. In case of AC, we have to convert in DC by using the rectifier, either controlled or uncontrolled. Regulation and control and protection for a synchronous machine. Now the point is that why we use the DC current, because the DC current provide the fixed polarity of the magnet. If we use AC, it will regularly converts south pole into north pole and north pole into south pole. But we need a fixed polarity, so we provide the DC current. The next one is the basics function of the excitation system. So excitation is nothing but the process through which we provide magnetic field to the field winding of the synchronous generator. It has basically two functions. One, to provide the direct current to the field winding of the synchronous generator, and the second one is the to perform control function, limiting function, and protective functions. Why? For the satisfactory operation of the power system. So how could this would be performed? How this could be accomplished? These functions are accomplished automatically by appropriate change in the level of the machine excitation. By changing the field excitation, voltage or current, we can accomplish all these functions. So the basic function of the control function is just to regulate the desired level. What is the frequency level, what you want to voltage level, voltage terminal voltage of the generator. So control function specifically pointing the set value, preset value of those, so that the frequency is only 50, Terminal voltage should be 25 kilovolt. So it's regulate a specific quantity at the desired level. How much power active, how much power reactive, how much total power, what should be the total angle, in which we divide this control function in three parts. One is the voltage control, another is the reactive power control, stability control, in which we control the rotor angle. It might be frequency, reactive power, active power, and so on. The next function is a limiting function. It prevents quantity from exceeding set limits. We have a system constraints, transmission line constraint, nodal voltage constraint, generator constraint, spare capacity constraint, tap changing constraint, or setting constraint. So limiting function ensure the constraint of the synchronous machine, excitation system, and other equipments are not violated. While the protective function come in picture when the limiting function unable to perform, it fails. When the limiting function fails, the protective functions take the appropriate component, take out the appropriate components from the system or from the service. So protective functions ensure that the capability limit of the synchronous machine, excitation system, and other equipment like transformer should not exceed it. Here we have a capability chart in which it is shown that the rotor heating limit, stator heating limit, prime mover limit, static stability limit, all these are limit are sketched here, which is we will found by very comprehensive study of the voltage stability, in which we draw a curve or chart that is called the capability chart of the synchronous machine. So the system should be operated within this region, this curve region. There is a over excitation limiter, under excitation limiter, a rotor winding limiter, a stator winding limiter, steady state stability limiter, which limits its capability, the maximum capability. So it should be operate in this region. Okay. Now the how should the excitation system perform? We define in different perspective, one from the point of view of generator and another from the point of view of the power system. The excitation system should be able to supply field current, automatically adjust the field current as the generator output varies within its capability, and respond to transient disturbances. So these are the requirement which should be provided by the excitation system from the generator point of view, from the generator consideration. The next one from the point of power system consideration. In this case, the excitation system should be able to effective control of the system voltage, that may be terminal voltage of the generator or any remote position voltage from the generating terminal voltage, and it should improve the stability of the power system, either transient, steady state, or dynamic. So these are the different consideration. One is the power system consideration and another one is the generator consideration according to which what excitation system should be, what what the system excitation system should have. Next, the basic elements of the excitation system. Here we can see that the power system, which is connected with the generator, obviously synchronous generator, which provide the power to the entire power system, that is the transmission distribution part of the power system. The generator will be excited with the exciter. It might be AC exciter or DC exciter. It depends upon the uses requirement. If we are using DC exciter, then it will and good. Will directly provide the DC power to the field winding of the synchronous generator. But in case of AC exciter, we have to convert AC into DC, and this can be done by successfully by using the rectifier, either controlled rectifier or uncontrolled rectifier. Now here is the voltage regulator which regulate the voltage. It might be AC voltage regulator or DC voltage regulator. Here we have used the rate feedback, that is the derivative feedback. Generally it is the PD controller. This feedback actually used to stabilize this excitation system, this excitation system. And this power system stabilizer used to stabilize the entire power system. Is it? Here we have the three-phase power at this point, at the end of the generator, because the synchronous generator is a three-phase generator and it will give the three-phase power. So this three-phase voltage will be measured by voltage transducer. Here we have a fixed set point, DC set point. So it convert this AC quantity into DC. It's compare with the set point of the DC value and send the error signal to the control for the controlling purpose to the voltage regulator. This voltage regulator will provide DC signal to the exciter. Here we have used the load compensator. It is used to compensate the load variation because it might cause the terminal voltage increase or decrease. The last thing, limiters. We have different type of limiters: over excitation limiters, under excitation limiters, voltage per hertz limiter, which are used in different condition, in different scenario of the power system, and the protecting circuits that we have already discussed. So this is all about the elements of the excitation system. So one by one, in the next class we will discuss what is exciter, what type of exciter, and all remaining syllabus. So